Hi everybody, welcome back to this YouTube channel. So proceeding from where we stopped from, in this lesson we're talking about fractional indices. We introduce ourselves to like normal indices, last time, telling you that index is basically referring to the number of times a base has been multiplied by itself. So for fractional indices now we are looking at a kind of indices where the power, like the index now, is a fraction. So like how do you interpret that? The one that we did before, a raised power 2, like 2 was a whole number, 3 raised power 4, 4 is a whole number, it's like that. But in this case, we are going to have like a raised power half, b raised power 3 over 2, blah, blah. So how do you deal with issues, like that? Now, if I asked you, what is root 9? Basically, you tell me, so let's say examples. So if I tell you what is root 9, yeah, I'm definitely going to tell me that root 9 is 3. But there's a way we can re-express this. What root 9 means is actually um, 2, a small 2, root 9. I'm not talking about this 2 root 9. This is like sword. And this one is different. But the small 2, then root 9. So what that small 2 is telling you is that root 9 is equal to a number. By the time you multiply it 2 times, we give you 9. So by the time you multiply that number 2 times, it will give you 9. That's the function of this 2. But usually, if we are talking about roots, like we don't bother to include 2. So if you are just looking for a root of something, don't bother to like include. So that's why I don't have 2 here. Like I said, it basically means this. And then 2 root 9 basically is equal to 2 numbers, 3 times 3 I can multiply, and I will give you 9. I'll give you 9. So root 9 equals 3. So in index form, how do we express this? So for you to express root 9 index form is actually 9 raised to a half. So you can put to your calculator now, 9 raised to a half or 9 raised to 0.5 will give you 3. So how does it now work? The 2 that is here is the one that comes here, 2, then put a root, then up to 9. So your 2 comes to the back of your root, close, you write your root and then you include the number that is here. So this 1 here means the 1 is on 9. Alright, so these 2 comes to the back, root 9, then root power 1. As simple as that. Let's look at root 25. Let's look at 25 root power half. Now 25 root power half, again, is 2 and root 25 root power 1. And this is going to give you 5. So 5 is the number that you have to multiply 2 times to get that. Okay, so this may look like, let's see if this guy is just trying to like scam us from all of these things. Okay, if he keeps scamming you, let's say, we do this. 8 raised power 2 over 3. Now, following the format that we've been using, the denominator of the power comes to the back, so this becomes 3, then roots, it's small 3, roots, then 8, then this square. Alright, so basically this is 3 roots 8 square, so that will give us 3 roots 64. It's a small 3. So what number can you multiply 3 times? That will give you 64. 4 times 4 is 16. 6 times 4 is 64. So that's how this will be 4. So plus or minus 4 actually. Do we need that? No. It's just 4. It's not plus or minus 4. So it's this one that is plus or minus 3 because minus 3 times minus 3 will give you 9. Plus 3 times plus 3 will give you 9. This one is plus or minus 5. Plus 5 times minus plus 5 times plus 5 will give you 25. Minus 5 times minus 5 will give you 25. But here, it cannot be plus or minus 4. Right? Because what's this even mean? What is plus 3 minus 3 even mean? For those that don't know, is that your answer is like plus 3, or minus 3. So plus 3 times plus 3 will give you 9 equals 9. And minus 3 times minus 3 will still give you 9. So we can't put plus or minus in down because if you want to put a plus or minus, say plus 4 times plus 4 times plus 4 to give you 64. But minus 4 times minus 4 times minus 4. Minus times minus is plus, yeah? But plus times minus will now give you minus. 4 times 4 times 4 will give you 64. So this will be minus 64. But the question is not minus 64. I just said plus 64. Alright. So I believe that is that is okay. So from there we'll now begin to like look at that's like the general thing about it. 8 0 power 3, like I said, the answer is 4. So any other thing that you guys want to do, just apply this particular principle. So generally speaking, say generally A raised power x over y equals y small y then roots A raised power x. So that's it's generally speaking. Okay, so from here, let's now solve a couple of exercises. So more before we then give you your assignments, exercises. So we're expecting that the exercise is going to like huge, right? So number one, we have A, we have 25, B raised power 4. Now, what does this mean? This means that, of course, what you have here is 2. So what number can we multiply 2 times? That will give us 25 raised power 4. If you don't know, so you could just separate them like root 25, then multiply by roots b raised power 4, and just do something like that. So what number will you multiply to give you 25? So you have 5. This is your plus or minus 5 anyway. Then multiply by b raised power 4. To get a number that I can multiply 2 times, it's still going to be b or b raised power 2. Because b raised power 2 times b raised power 2 equals b raised power 2 plus 2, which is 4. Alright? So we are going to be having our answer to be plus or minus 5b squared. But usually you just see in your textbook, you just see 5a squared. And it's okay. It's okay. So 5b squared. So when you multiply 5b squared times 5b squared, you're going to have 25 raised power 4 back. Now for b, our next question says 3 roots 8, then everything, 3 roots 8, then everything raised power 3. Okay, so what number can we multiply 3 times by itself? That will give us 8. 1 times 1 times 1, 1. 2 times 2, 4, 4 times 2, 8, that's 2. So we're going to be having 2, then raised power 3. It's that simple. So you have to solve this guy out to the raised power index of 3, and this is going to give us 8. So our answer there is 8. Now C, 27 raised power minus 2 divided by 3. Now, this, of course, will give us 1 divided by, remember that law, whenever you have a negative power, 1 divided by 27 whole number 2 raised by 3. Let's start from there. And then this is now going to be equal to 1 divided by 3, this denominator, 3 roots 27 raised to power 2. 7 raised to power 2. Alright, so I could actually just do something. I could just do 1 over 3 roots and 27 raised to power 3. Still the same thing. So just not to like make the whole thing complex for me. So I have 1 divided by what number will go in 27? What number will multiply itself like 3 times? That'll give me 27. So that's 3. 3 times 3, 9. 9 times 3, 27. So I'm going to have 3 here. 3. Then 3 raised to power 3. 3 in this place, then raised to power 3, which is equal to 1 divided by 27. So that's the answer to that. So, or you could have decided to also do 27 times 27 times 27. Alright. So in this case, if I decided to do 27 times 27, instead of like from, okay, I mean here. So if I decide to do 27 times 27, I'm going to get a number. No, sorry. This is meant to be 1 over, this is square, sorry. And this is 3 squared. And this is 9. Yeah, I'm sorry for that. Alright, so if I decide to do 27 times 27 there, I'm going to get a number. Right? So the number that I'm going to multiply like 3 times to get whatever that result is going to be is still going to be 9. Right? So you could try it out, and then so you could try it out. So you can see you will see that it's going to be the same thing. Or we will try it out ourselves. 27, 7 times 7 is 49. 7 times 2 is 14, plus 4 is 18. And 2 times this is 54. So you have 9, you have 2, you have 6, 6 to 9. is it 6? We have 7 rather. 729. Okay, in the same vein, if you do 9 times 9, so 9 times 9 times 9, so you have 81 multiplied by 9. 9 times 1 is 9, 9 times 8 is 72, so it's still 729. So there's no problem with you first getting three numbers you can multiply to give you this and then squaring what your answer. Like there's no problem with that. But if you think that this is what you want to do, first square it, right, and then get a number. So if you first square it, you're going to get 729. The number that I can multiply 3 times to give you 729 is still 9. Alright, so it's just it's okay that way. Um yeah. So there's a fourth one that is a little bit funny. Finally, we have to deal with these two questions before we bounce, and you get your assignment, and that'll be the end of it for now. So when you see something like this, normally you're meant to be scared. What's on earth is this? But let's just try to like solve it using computing the squares method to see if things can be made a little bit easier. So what I can just do is the way you get answers using computing the square method. So that means we are looking for two numbers and when we multiply them, we are going to get this time this is s squared, y squared. And when we add those two numbers, they will give us 2xy. So from this, I don't know if you have seen something. That means xy plus xy. Or let me say 1xy plus 1xy. That will give us 2xy. And xy times xy give you s squared y squared. So that means what we are looking for is just xy plus xy. X times x, s squared. Y times y, y squared. And 1xy plus 1xy give us 2xy. So this is just what we are looking for. All right. Solving it properly, d roots s squared plus 2xy plus y squared would then be using computing the squares x squared then plus this xy plus xy again then plus y squared. So remember that we used to do this. This is just quadratic equations. Although we are still going to teach as a topic, we've done it like we've not taught it as a topic, but we've been using it in optimization questions. Alright, so you might not be an economics student that you stumble on this. I might be wondering like, why is economics on it? Okay, this is part of mathematical economics at universities because the understanding of you're not doing this just because you want to do this or because your lecturers want to stress you. You are doing this because you've been doing the understanding of this in other things that you're going to be doing that are economics related. Right, so that's how you're learning all of this. So using your computing the squares method, we get here. Of course, you cannot use the general formula because your answer is not going to be like one number. Your answer is going to be in terms of letters and all of that. Okay. Um, or you can use general formula anyway, but that is not going to give us what we want it to give us. We are not trying to like solve it and get the exact answer. No. You see what I'm trying to say? So from this place, collect x, once take x out, we're going to have x plus y, right? In this place, y is common. Take y out, we're going to have x plus y. So you see at the end of the day, you have this x plus this y, because when you are solving quadratic equations, what you have in the bracket is the same as what you have in the bracket here. Alright. So then what do you collect? Collect this and this. The x that is standing out here, then plus this y. And you take one of this, take one of this because they must be the same thing anyway. So just take one of it. In this case, they just happen to be the same thing, x plus y, x plus y. So this is how we are stopping for the question we want to solve. So what this means is that roots s squared plus 2xy plus y squared is actually equal to roots x plus y, x plus y. And then what would your be answer? The answer is just x plus y. That's all. But it is x plus y that you multiply, that you can multiply by itself two times. That will give you what is inside of this root. So that's why I said it's not really advisable to go use general formula because we are not looking for a number. We just want to see if there are two things that we can multiply that will give us what is here. Like if there is a number or an expression that can multiply by itself twice, that will give us this. Then when we use the computing the squares method, we figure that, oh, okay, yeah. there's something x plus y in two places. So, and then that means x plus y is going to be the number that we're looking for, or it's going to be the expression that we're looking for. So for the last one, E, we have 9a squared divided by 25, everything raised to power minus half. Okay, what this means is that you have okay, one person could solve it this way, that you have 1 over root all of this 9a squared divided by 25. You got me right? So which is like equals 1 divided by root 9a squared over 25. So what's that's going to give 1 divided by um, root 9a, or let me still simplify it, root 9a squared over root 25. I think this should be easier. So I'm going to be having 1 divided by, first root 9 is 3. So you have 3 roots a squared, since it's just 2 roots. So that's a. A times a will give you a squared. A. Then this is a. And divided by root 25 is 5. So we have 1 multiplied by 25 over 3a. So the answer is 25 over 3a. I think that should be it. Is it? Oh, sorry. Root 25 is 5. Um, root 25 is 5. So this is 5 over 3a. Alright, 5 over 3a. Alright, so since it is just two roots, I could do plus or minus 5 over 3a. That is plus 5 over 3a or minus 5 over 3a. Yeah, answer. So that means for this other one too, this should also be equal to plus or minus. So whenever the number before your roots is even, an even number, right? Like let's say 2, 4, yeah, you have 4, 6 is also an even number. So plus or minus should be at the end of your answer. Plus or minus. Why? So I think I showed you the other time, fire up of the board, that plus 5 times plus 5 we give you plus 25, right? Then minus 5 times minus 5 we still give you plus 25, because minus times minus will give you plus. Right? So if it was like 4 root something, so let's say you have 4 roots a raised power 4, and that's going to give us like a in 4 places. So that's going to give us like plus a times plus a times plus a times plus a. Since everything is plus, I'm going to have plus a raised power 4. In the same way, minus a times minus a times minus a times minus a. Minus times minus will give you plus. Plus times minus will give you minus. Then that minus times the last minus will give you a plus. Right? So whenever the number here is even, so your final answer should be plus or minus. But if it were odd, right, then you have to be careful. If it were odd, if it were like 3, do you understand, or 5, so you can't have plus or minus. Only one of it that's going to work. Okay, so that's that. So let's say you have roots of minus 27. Sorry, 3 roots minus 27 will give you minus 3, but 3 roots 27 will give you plus 3. So yeah, that's the next thing is 1 or 2 assignments for you guys, and then that'll be the end of this lesson. Following anyone I can start first, you don't have to necessarily start with A. Anyone I can demystify first, so you demystify it. So a² raised power 3 divided by 27p raised power 6, then all of them are raised power minus 1 over 3. As for A, then for B, the easiest of all, 1 to 5 raised power 3, close the bracket, raised power 1 over 3. Then C is 3 whole number 1 over 5, so it is not 3 raised power 1 over 5. 3 whole number 1 over 5 multiplied by 20d raised power minus 3. Close the brackets, then raised power 1 whole number 1 over 3. Then D 3 root 64 times 8 raised power 2 over 3 times 16 raised power 1 over 2. So yeah, thank you very much. See you in the next class. So we shall be talking about indices and exponential functions. Right. So indices and as exponents. So something around exponential functions and indices. All right. Bye. Have fun. See ya.